So my talk is how I use Eleventy to power a world-class museum's digital infrastructure. I have to thank Sia for coming up with a much better and more concise title of Eleventy at the museum. I wanted to give this talk because I think we hear a lot about the classic use cases where a static site generator like Eleventy is an obvious good fit, right? Things like marketing blogs, sites, stuff like that. But web tools like Eleventy can be used to power things that don't necessarily exist on the open web. And in this case, the web becomes more like the medium, which you can use to create other cool things. And I thought this topic might be of some interest to the audience. To give you a tiny introduction about me, my name is Nic Chan. I am an independent front-end developer from Hong Kong. I make up one half of Ultramarina, where we just launched an accessible Shopify theme called Primavera, so check it out if you're interested. And I am available for hire. I specialize in general front-end development and accessibility consulting, so feel free to reach out if you're interested. So our story for today takes place at the M Plus Museum, which is pictured here. It's in the West Kowloon Cultural District in Hong Kong, and it's a relatively new museum. It was a part of Hong Kong's larger plan to turn itself into like a cultural and artistic hub, and it only officially opened its doors in 2021, which is 4 short years ago, but feels like forever ago because of COVID. And this meant that the entirety of the museum's lifespan existed in the digital age. Unlike a lot of older art museums, which have maybe hundreds of thousands or even millions of objects, and all the technical depth that brings from transitioning to paper to digital systems, M Plus didn't have to do this transition at all. They could just start operating in a digital first landscape. And to set up the foundation for this digital first museum, M Plus hired a team with strong digital expertise, with people who had worked mostly in tech, whether it be agency work or product work. And these folks would lead digital projects in the museum, and they wouldn't necessarily execute the work, but they would maintain and oversee the work. And they would also liaise with other less technical departments in the museum in order to make sure the projects kind of happen. And one of the most important decisions made by this technical team was to adopt a headless architecture. For the general public, we have like open access to the Objects API, and this allows people like art researchers, students, to study the collections. And internally, the M Plus team would manage everything from the open source CMS Wagtail. And these would be used for like all the art objects and artists and things like that, but also things like events, their main website, all the publications they do, stuff like that. And setting up this foundation properly let them extend their digital presence without being too reliant on a single vendor. Instead of having like one mega agency that would have to maintain a bunch of different projects for them, they could just hire a wagtail specialist to do the CMS bit and then the various front-end vendors to do the other bits, and that would minimize the level of overhead required. And this is where I come in. Initially, I was brought on to do 6 tiny projects right before the museum launched in 2021. I worked on a very small team of 3 people where we had a project manager, a designer, and me to serve as the only developer. And it was basically a kind of like fill in the missing pieces job. They had all these moving parts and the integrations were already underway. I just needed to provide all the bits that would finish off these efforts. The digital team at M Plus being technically oriented meant that they had the option to be agnostic about technology choices. They weren't saying things like, we need a React application. They were open to any option that would solve their problem. So the deliverables for a lot of these projects ended up being things like simple static HTML and CSS pages with a small twist. For example, one core requirement of all the projects was internationalization, and I think that's going to be a recurring theme for tonight. Hong Kong organizations generally need to have 3 languages. They need to have English, traditional Chinese, and simplified Chinese. And yes, while you can maintain static HTML and update this, it gets out of hand super quickly, especially when you're working with clients going back and forth. It's just easier to have like some kind of generator system. And finally, this is where Eleventy comes in. I chose Eleventy for a few reasons, and I'm sure some of you will find these reasons relatable to you. After writing these, I actually discovered that the Elementi website has pretty much this exact same content on the Why I Choose Elementi page on their website. But I want to reiterate, I did write these. It's not just marketing fluff. I really do believe this. The first is that Elementi allows you to have full control over the markup and output. This turns out to be super important, and I'll go into a bit more detail later. A lot of the newer static site generators take a bit more of a opinionated approach when it comes to asset management and bundling. And this is fine for most use cases on the web. But as you'll see, this is not a typical use case. So fine-grained control is really important. We needed to be able to pull in data from different sources. Stuff like translations for things in the UI probably wouldn't change, and that's fine to just live as JSON files in the repository. But actual content would need to come from the M+ APIs. And occasionally we would need to glue or reshape the data into different structures to make it work for the projects. And Elementi makes this all a breeze because they let you transform the data however you want. The third reason is stable and low maintenance updates. The way that most of these projects works is that they would be rebuilt regularly on a specific timeline. And by rebuilding, I mean like an Elementi build, not like completely revamped from scratch. The site just needs to be regenerated fairly frequently, maybe several times a day or once a day. And the last thing the team needs to worry about is, the framework needing regular updates or dealing with breaking changes for many small projects. The fourth reason is that Elementi's simple approach meant that handoff was super easy. Without much training, the team was able to make small changes and improvements on their own, and this is always a goal I have for projects that I hand over. I don't like it when clients feel lost or like they've now inherited some kind of huge technical monster that they have to maintain. And finally, one very key reason is that using a static site generator means that you know all the content that will be there on build. For CJK languages, which is Chinese, Japanese, and Korean, you have like several thousand characters. And when you put the whole font in, those font files can be like 4 MB large. And if you want to have like better performance with fonts, what you typically do is you analyze the content, you look at all the characters that are in that site, and then you take a snippet of the font that just has the characters you need. And actually, I think, our Lord and Savior, Zach Leatherman, has written many helpful tools to help with this because he also does a lot of font-based work. And I'm pretty sure I use these tools on the projects as well. So on to the mini case studies. The first example is a Wi-Fi captive portal. And this is one example where Elementi was a super obvious choice. When you log into a free public Wi-Fi network, there's usually a page that will ask you to fill in some information and accept the terms and conditions before being granted access to the network. Basically like Wi-Fi jail. They had a vendor that would do the backend bits, and they just needed someone to make the branded front-end templates with the specific content and terms, and they needed this to be delivered as HTML files. They would take care of all the routing and stuff like that. And this is a use case where Elementi really shined. The templates had a overall pretty similar layout, but they needed tiny tweaks. For example, depending on which floor of the museum you're in, you would have different color schemes or you would have different success state blocks. Like if you're on the second floor of the museum, you don't see this get tickets block because you're already in the museum. You don't need to get tickets. You'll see something else relevant to that floor. Generating all of this as static HTML files meant that we didn't need to add any complexity on the client. The logic for showing the correct page to the user was all in the routers. You would just connect the second floor router to show a specific page, stuff like that. And this way, we were able to keep track of all the complexity of having slightly different pages for locations and languages. Our next mini case study is on the digital signage solution. We don't necessarily think of things like signage as being part of the web, but the web is actually the perfect medium for things like this. This poses a really interesting inversion of the typical dynamic you see on the web. On the web, you might be making your website for an infinite combination of devices and browser versions, but digital signage is the opposite. You're making things that are meant to be displayed on only a handful of specific known devices with locked browser versions. And this means you don't have to care about certain standard problems on the web, like cross-browser support. Even things like security can be handled at a different level. It's not actually a huge deal to put your API keys in the front end code because you can kind of tackle it on like a network level, right? Like maybe you can block all connections that are not internal. And so you can have more sensitive things in the code, even though you probably would not want to do that on a regular website in production. And theoretically, this means that the solutions should be easier. But vendors like to sell all-in-one solutions. They want to sell you the hardware to power the signs, and they want to sell you the software to manage it. And they like to do like, drag and drop sign builders and things like that. But sometimes that causes more problems than it actually solves. For example, in this case, M+ wants to just use it to display the museum's daily events, and they want to have different signs at different parts of the museum. Had they opted into the digital signage software, they would have to add the same events in two different CMSs. Two different user interfaces is more room for error. It's just not a good experience. And in this case, they wanted to use the CMS that they already had. So here are our basic specifications for the signage solution. It's pretty straightforward. It needs to connect to the M+ API. It shows the next 6 events of the day. It updates every 15 minutes, and it's display only. There's no interactivity, no clicking, no touchscreen. And you need different layouts, color schemes, and events for different locations. So the cinema signs should show only the cinema screenings, and we can do all of that by filtering the events you get back from the API. And some signs are horizontal and are paginated across 2 displays, and some are vertical. And so here's a picture of me and the sign. Funny story, I asked my mom to take a picture of me with the sign because I feel like as web developers, we don't really get to see our work in the wild that much. So being able to see our work like just existing is kind of novel experience. But once we took that picture, then like a couple next to us like also decided to take a picture with a sign, but I'm like, this is not interesting to people who are not me. And you can see from the pictures that the layouts are pretty straightforward. They're very typographical. The events are just kind of laid out in a grid. And this kind of layout is super easy now with the tools that we have with CSS Grid, things like that. But here comes the first wrench in the story. I was informed that the signs were using a fork of the Chromium engine, and under the hood, the version that it was pinned to was Chrome 50. Chrome 50 came out in April 2016, which meant that I had to put away most of the tools that I know and love now. And on the screen now is a screenshot of Can I Use, and it shows you the browser support for CSS Grid. CSS Grid officially landed in version 57, and this was really sad for me because it meant I couldn't use CSS Grid. And so we had to hard code sizing stuff instead of letting things flow, which is something I would never do in a regular website scenario because you need to support flexible content and font zooming. But for this, it's okay because it's a static signboard. And from an architecture perspective, I had planned to do something that would use client-side JavaScript to make a new API request every 15 minutes, and then it would kind of replace all that content on the sign seamlessly. I had written all the data fetching and transformation code, and then the team kind of dropped the second major hurdle for me. And they mentioned it really casually. They were just like, oh, by the way, the signage browser doesn't support JavaScript. You weren't planning on using JavaScript, were you? And at this point, I was really glad I had chosen Eleventy because depending on what stack I chose, switching from that solution to something else could have been a lot more work. I know now it's 2025, but if we take ourselves mentally back to 2021, React server components didn't exist yet. Astro hadn't even released its 1.0 version. Being able to serve just static HTML was not always a guarantee with some static site generators. And because I had relied on core web technologies, the switch was pretty trivial. I just copied my client-side JavaScript to the server, and then my Nunjux templates could pretty much stay the same. But that doesn't solve the problem of how to get the signs to refresh. How can we do that without JavaScript? The solution was pretty simple. HTML has a meta tag that lets you automatically refresh the page on a timer. So the snippet here, it just tells the browser to refresh every hour. And then we just have to get Eleventy to rebuild on set intervals by using functions. So this ended up being a pretty low complexity solution for content that needs to be updated. And while we could have used something like a standard server-side framework, but we have to remember that this was a solution that we landed upon after having to pivot. It's maybe not a super ideal solution, but I think that having the downtime between the switching the signs was actually a better user experience, because if you make an expensive like server call that takes a lot of processing, the sign could be blank for a while. And with this use case, you really want it to be refreshing as fast as possible, and static HTML is the best way to deliver that. I ran some really rough numbers here, and this solution actually costs them around 1/20th of what it would cost them from a digital signage solution provider, not to mention like the uncountable number of man hours needed to update the event content in multiple places. So I think we still came out on top here. After delivering the initial round of projects, the museum was pretty happy with Eleventy and all the things that you can do with a simpler approach. And they accepted me for another project, which was to improve upon their audio guide solution. And that was a much bigger project. The audio guide has two kinds of tracks. It has a commentary track, which is usually by like a curator or a specialist, and a audio description track, which is a type of track that provides information to blind or low vision visitors on what the artwork looks like. So on the screen now, on the left, you see a screenshot of the visual labels used for both type of tracks. It's printed on the wall next to the exhibit label or the artwork label. And it's not pictured, but there's also like Braille. So if you cannot see the label, you can kind of like feel out what the track number is. And on the right, we have a photograph of the printed booklet of tactile maps. And that's like kind of like a raised map that will show you the layout of the galleries. And it will also show you where the artwork and what track numbers are in the galleries. So, and people would like borrow these booklets and then take them around the museum. So you always can orient yourself on your own. While I want to highlight disabled users as the primary beneficiaries of audio descriptions for a very modern museum like M+, many visitors can benefit from audio descriptions because sometimes you don't even really know what you're looking at, especially for really conceptual artworks. So many people could benefit from this as well. This app needed to run in two main contexts. One is on a user's personal device, so your own phone that you're bringing to the museum. And you also need to be able to run on a device that the museum would lend out to people. And they had an existing solution from a vendor, but it was pretty terrible for users in a number of ways. The first reason was that it was a client-side React application built with React Native. You would think that React wouldn't be a terrible choice for this. There is a level of interactivity required, and there is client-side complexity in the components, so the seamless loading between the pages would be a nice experience. However, this was not implemented well. Upon choosing a language, the app would automatically download 2 gigabytes of audio files onto your device, and that would just completely destroy any data plan for most people. For those of you familiar with progressive web apps, you might know that iOS has strict limits of how much stuff you can put into cache, which is only around like 50 megabytes. So that means that for this app that was downloading 2 gigabytes of audio files, it needed to be published in the App Store as like and the Play Store. And that would create further barriers to entry. You can't just jump in. You need to know about the app existing first. And in practice, this means that users had to locate like a specific sign in the museum that had 2 QR codes on it. You would have to scan the right one, download the app, choose your language, and then wait for your 2 gigabytes of data to finish downloading, and then you can start using the audio guide. And that makes for a really terrible experience. Though it might be technically easier for developers to make something that has this like single entry point, it's not respectful to the user to download that much data, especially for something that users will only use for a single day while they're in the museum. And worst of all, this solution wasn't screen reader accessible. It's a shame because for some people, this app is going to be the only way they can experience the museum. And this app being not accessible lets those people down. On the admin side, this being an all-in-one solution meant that the data needed to be uploaded into two places, which is the exact problem that the museum was trying to get rid of by doing the headless thing. So now that we have our problems outlined, it's time to think about the solution. We really wanted it to be a progressive web app to minimize the onboarding friction, and that involved some changes on the museum's part as well. With the old app, you had no way to use the audio guide once you're in the galleries. There were stories of people seeing a label saying that the audio track was available, and they would ask museum staff in the galleries, like, hey, how do I get this app? And then they would like pull out these printed QR codes and be like, you can download it from the store. And then they would like load the 2 GB, and it was just not a good experience. The museum would add QR codes directly to the wall so that a user would be able to scan the QR code and immediately be directed to the landing page for any track. At first, they wanted me to build a camera application into the progressive web app, but I convinced them that by relying on the user's camera, it would make it easier for users to start using the audio guide while in the middle of the gallery experience, without having to plan to use it in advance. From a tech stack perspective, obviously, I ended up choosing 11T for this approach. I had offered the choice of web components for the areas where we needed JavaScript, but the team wanted to use Vue as that was what they were more familiar with. So I proposed Petite Vue, which is only 6 KB, in order to keep things light. And that was a pretty good compromise for their developer experience and also like the experience of users. And we made really heavy use of service workers, which we used a different service worker depending on if it was the museum's device that they were loaning out or the user's device. In my personal opinion, service workers are really overlooked in terms of what it can do to level up a static site into a more app-like experience. And this is because service workers are really difficult to write and really difficult to debug. So if you're interested in service workers, I would strongly recommend Jeremy Keith's book Going Offline because it provided a really valuable resource as I was executing this project. Anyway, back to the point. For the museum's devices, they had procured some like mid-end Android devices, and we implemented a service worker to download absolutely everything. Basically, like what the original app solution was doing. So if the Wi-Fi died, then people could still use the audio guide in the museum and borrow those devices. And the content on those devices, all of it was preloaded, and there needed to be a mechanism to invalidate the cache. And for a user's device, we would implement preloading, but more selectively. Let's take a look. So upon scanning a QR code, if the user hadn't visited the audio guide before, the user would be directed to the language selection page. But language, once you selected it, would be saved in a cookie. So users scanning subsequent QR codes in the gallery would land straight on the track page. You wouldn't have to choose a language again. And when a language was selected, we would also preload a bunch of key pages and assets into the local cache. So it'd make for a instantaneous app-like experience without actually being a single page app. And once a user navigated to a page, we'd save that page into the cache. So if you're going through a tour, then we would save that tour index page once you landed on it. So if you ever went back, it would be instant. And this approach was more respectful of a user's device and browsing habits. Most users are not actually listening to all 2 GB of tracks when they're visiting the museum. They're listening to the ones for the objects that really catch their eye. And in relation to this point, I want to emphasize how important it is to support the multiple entry points. We've already discussed QR codes, but it's also important to support a keypad functionality because fully blind users can't see the QR code or know where to aim the camera. So a lot of them would be relying on the Braille numbers, and having a keypad that is screen reader accessible will allow them to access the tracks without assistance. And users could also browse by tours, which is kind of like having a personal docent. It would just take you through the whole exhibit in the order that was intended. We really wanted to make sure that a user who is just scanning a QR code one time in the gallery has just as good of an experience as a user who is going through a tour or a user who's using a keypad. So supporting those multiple entry points was really important. And that's something you can do when your app is just HTML pages, because you just kind of point people to the correct page to start. Here are some screenshots of the location page. You have some basic information about the artwork to orient the visitor so that they know they're looking at the right object. And you can choose between the commentary track and the audio description track. The bottom of the page has an audio interface with standard functionality like speeding up audio, skipping forward 10 seconds, stuff like that. And of course, there is an audio transcript. Overall, the project was a huge success. Adoption was generally good. There are several hundred visitors a day that use the app compared to nearly non-existent numbers before, and it remains an important part of M+'s accessibility strategy. Every time I go to the museum, when I see someone just take out their phone and start using the audio guide within the exhibits, I feel really happy, like I've done my job well. Now that it's been a few years since this project has launched, there are some things I would love to go implement if I had the opportunity to revisit again. The first is critical CSS. Elementi's bundler has gotten so much better since 2021. They have buckets where you can kind of put different CSS and JavaScript into different parts of the site. And I think it would be amazing if we could just inline the CSS needed for each page on each page, because we're doing a lot of preloading anyway. The second is more intelligent preloading. We do utilize some, but it would be cool if we could step it up. For example, if we preloaded the audio and HTML for the next track while you're on the previous track, it would make it feel instantaneous. And the final thing is dynamic transcripts. Transcripts are really important accessibility feature for people who can't hear, but it can also be used to answer things like, how do I spell this artist's name? Or what was that cool word I heard? It would be also really awesome if the transcript would kind of scroll as the audio played. My final takeaway here is that even though there are things that can be improved with this app, this project really benefited from relying on a web-first approach. And that's something that 11T made super easy. With things like this, you're getting a ginormous range of devices. You have people on their state-of-the-art iPhones, and you also have the museum's devices, which are devices that are inevitably going to be, several years old and cost-effective, not the latest iPhone at all. And it was really important to pick an approach that supports both kinds of hardware. You don't want to weigh down the browser with client-side JavaScript. I truly believe it's much easier to take a tiny little web app that uses the fundamental underlying technologies of the web and then take some time to really feel out the successes and failures of people using it in the world and then extend it rather than just kind of like throwing the whole kitchen sink at it in one pass. And that's it from me. Thank you all so much for listening. I hope this talk has opened your mind a bit about the potential of Levity and a web-first approach to building things. If you want to chat more, you can find me on my personal site, nickchan.me, or Blue Sky or Mastodon. Thank you.